Right, back in another OMG, it's core chemistry, and today we're talking about elements, compounds and mixtures. So first off, we're going to talk about the difference between an element, a compound and mixture, and the key definitions that you need to know. So elements are pure substances and they are found on the periodic table. Elements contain only one type of atom, so that's the definition of an element that you need to know. So elements contain only one type of atom. Compounds are two or more different elements chemically bonded. Chemically bonded. They have to have a chemical bond. Mixtures are made from different elements or compounds mixed together that are not chemically joined. So different elements, different compounds mixed together, not chemically joined. Mixtures can usually be separated by physical techniques such as filtering or distillation. A molecule is a cluster of non-metal atoms that are chemically bonded together. Okay, so atoms, one type of element, so one type of atom, there's only one type there. Okay, you can have hundreds of them, but it's just one type. Molecules are normally when something's diatomic, so it naturally exists as a pair, so they're bonded together. They're still elements, normally non-metals, but they're bonded together, but it's the same, so molecules normally pairs. Compound then, two or more different types of elements chemically bonded, and then a mixture here, you've got a compound there, different elements, but they're all easily separated because there's no chemical bond. So how do we separate these mixtures? So there's kind of three main ways you need to know plus chromatography, okay? So we'll do these three first. A mixture is made from different substances that are not chemically joined. So there's a mixture, imagine you've got Skittles. How would you separate out all them Skittles? You'd basically separate them out based on their colour. Okay, so that's an easy way to separate them mixtures. You could do that with some mixtures, but some mixtures maybe are a little bit harder to separate. So filtering is used to separate an insoluble solid from a liquid. So you've got water mixed with chalk. Chalk is insoluble, so it won't dissolve. How do you get the chalk out from the water? You filter it using filter paper and a funnel. Filter it out. The water should then end up in the flask and you should have the chalk left as a suspension at the top. So that's if you've got an insoluble solid. Evaporation then is used to separate a soluble solid from its solution to make crystals. Okay, so what you do is you heat the solution, normally in an evaporating basin, you could do it in a beaker. So the water evaporates and the soluble solid is left behind. So the water will evaporate. You could collect the water after if you wanted to, and you'll be left with the soluble solid at the bottom. Distillation is a little bit more complicated. Distillation is when you separate liquids in solution, so two different liquids mixed together. It can also be used to separate salty water, which is obviously not two liquids, that's a solid dissolved in a liquid. The method works because the water evaporates from the solution, but then it is cooled. So what we do, you can use it to separate ink, or you could use it to separate ethanol and water. Okay, ethanol has a boiling point of 78. Water is 100. So what you do is you boil it to 78. That's why you've got the thermometer. Okay, you could boil it to 78. The ethanol would start to evaporate, turn from a liquid to a gas, would start to evaporate, and then you pass it through this condenser. Cold water's passed through there and it would condense and turn from a gas to a liquid. Okay, and then you could collect the one. Okay, that's why the thermometer is so important, because obviously as it gets above 78 to 80 you have to stop them because you won't be able to get a pure mixture. Okay, you can do it with salty water as well. Water obviously boils at 100, so you boil up the water till it evaporates, turns from a liquid to a gas, pass it through this condenser, which is cold water, and then collect the sample of water. And then finally chromatography, which is a little bit different. Okay, chromatography is used to separate a mixture of coloured compounds, often ink or food colouring. As the solvent water soaks up the paper, it carries the mixtures with it. Different compounds of the mixture will move at different rates. This separates the mixture out. Okay, so if you look over here, you've got your baseline, which is always done in pencil, so it doesn't affect your result. You place it in water, so it's just below the baseline. Don't cover it in water. You only want a little bit on your filter paper. Put your ink spot, and as the water travels up your filter paper, it'll move them, and they'll all move at different points, and these are components, the things that make up that ink spot. Okay, So separated compound mixtures can be identified by calculating its retardation factor. Okay, retardation factor. RF value, distance moved by compound divided by the distance moved by the solvent. Okay. So you've got your baseline, like I said, that will be in pencil, so it doesn't affect it. Then with a ruler, you can work out how far the solvent's moved. It's the solvent front. Okay, in this case, it's 6. So the solvent's moved 6. How far has the substance moved? Substance has moved 3. So then you just do 3 divided by 6, and that will give you the RF value. Okay, the RF value is a measure of how soluble a particular substance is. The further the substance moved, the higher the RF value, so the more soluble it is. So, quick knowledge check. Pause the video, have a go at the questions, and see how far you get. So, what is an element? Something that contains only one type of atom, and them elements are found on the periodic table. Two or more elements joined by a chemical bond. What is a molecule? Atoms bound together, non-metals. Okay, so a molecule is like that, normally diatomic, so just as a pair. How do you separate mixtures? We could evaporate them, we could filter them, we could use distillation. So how does distillation work? It works based on boiling points. So it relies on you knowing the boiling points. So say something has a boiling point of 80 degrees, boil it to 80 degrees, it will evaporate. Okay, so it will be a gas, it then pass through the condenser and turn back into a liquid, and then you can collect it. The condenser is like obviously a cool water passing through. How does chromatography work? So it separates ink samples. The more soluble one will move furthest. RF values, so you do distance moved by solute over the solvent front. Okay, if you got them all right and you're feeling pretty confident, move on to the next video. If you didn't, go back and watch the video again and then try the questions again.